This is lesson 1.4 on the distributive property. So we have a group of 7 adults and 6 children are going to a University of South Florida Bulls baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. Basically, the distributive property is 2 different ways of coming up with the same answer. And we'll discuss this more in the next slide. But if you look here, the chart tells us the cost of different types of tickets. An adult single ticket's $5, children single game 12 and under are 3, groups of 10 or more for a single game are 2, and seniors single game 65 and over costs $3. So what do we know from the problem? Well, we know that there are 7 adults and 6 kids going. Do I know the age of the kids to see if they're 12 and under? Not really. But I do see that I have 13 people going, which is a group of 10 or more. So I can use this from the chart and know that each ticket is going to cost $2 for a single game. So we could do this in a couple ways. We know that 7 plus 6, that was 13 people going, and they're going to be charged $2 each. So this is $26. Likewise, on the other end, you could take 2 times the number of adults going plus 2 times the number of kids going and kind of separate it out there. So 2 times 7 is 14, 2 times 6 is 12. This also gives you $26. So notice on the distributive property, all we're doing is taking that front number multiplied inside. And I know last year you did a lot of distributive property, so hopefully this is pretty straightforward and easy to follow. So distributive property makes the mental math easier. So looking at this baby picture here, b times a plus y gives you ba plus by, or baby. So instead of doing 4 times 36, because I can't really do that quick in my head, I can break up the number 36 into partial sums there. The 10 spot and the ones place. So 36 is the same as saying 30 plus 6. And then we can use the distributive property. 4 times 30, like shown here, is 120. And 4 times the 6 is 24. And I could easily add those 2 together to get 144. That's a lot quicker than me trying to figure out, okay, 6 times 4, that's 24. Write the 4, carry the 2, or do some lattice. So try to apply this when possible. So I'm going to do the question up above. Use the distributive property to rewrite 7 times 49. So I don't know what that is off of the top of my head. I can show you one way using addition and one way using subtraction. So instead of 49, remember, you can put the 7 in the front and break this up into 40 plus 9. So this is going to be 7 times 40 plus 7 times 9. So 7 times 40, that's a nice 280. 7 times 9 is 63. And if I add those together, I get 343. So instead of using addition in the middle, you can rewrite 49 using subtraction. So 49 is very close to 50. So I'm going to write this as 50 minus 1. That's the same as saying 49. So 7 times 50 minus 7 times 1. So 7 times 50 is 350. 7 times 1 is 7. If I take 7 away from 350, I also get 343. So whether you want to round it up or round it down, it's easy to multiply by 10, 20, 30, 40, some of those numbers that end in 0, so that's what you want to try to look for. All right, a vocab term, coefficient. This is the number that comes before a variable. So you're going to be dealing with a lot with the coefficients here on the next examples. So for example, I have 7x. The coefficient is a 7. If I have negative 2ab, the coefficient is a negative 2. So it's just the number, it's not the variables. So rewrite each expression using the distributive property, then simplify. So I like to draw these little arrows so I know to go to both parts inside the parentheses. A common mistake is students would only go to the one, but not to the second one. So I'm going to rewrite this and show what this means. This means 7 times 3w minus 7 times 5. And when it says simplify, you have to combine some of the coefficients. So 7 times 3 is 21w, and 7 times 5 is 35. So we'll get into what like terms mean later, but you can't put this together because 1 has a w and the 35 does not. So 21w minus 35 is your final answer. This 4 is in the back. If you want, you can move it over and put it in the front. Some students like to do that automatically. They like to distribute forward instead of backward. So now I'm going to do that into the middle and to the third piece. So I need 3 different things. So 4 times 6v squared plus a 4 times a v minus a 4 times a 3. And simplify. So the 4 times the 6, that's 24v squared. You can write the middle term as just a 4v, drop the parenthesis, and 4 times 3 at the end would be minus 12. And you leave your answer like that. You have v squared, a v, and no v's, so you can't combine any further. So let's just go through these bottom 4 examples quickly. So 8 times 2 plus 4n times 2. And if I simplify that, that equals 16 plus 8n. And that's your answer. Next problem, you're distributing a negative 3 to both terms inside. So this is going to be 2 times negative 3 minus 5q times a negative 3. And simplify. 2 times a negative 3 is negative 6. And minus, or a negative 5 times a negative 3 is going to change this to a plus 15q. So just be careful on that one with the signs. Common mistake is students rush through these and the signs get all messed up. So I'm distributing a negative 6 on this third one. So this is negative 6 times r. And a negative 6 times a 3g. And another negative 6 times a negative t. So this simplifies to a negative 6r, negative 18g. 6 times 3 is 18. And on the end of this one, you have a minus times a negative, so 2 negatives make a plus. So at the end, you're going to have plus 6t. And the last one, negative 4 times negative 8. And a negative 4 times a negative 3m. So watch that sign in the center. This becomes a negative times a negative is a positive 32. And another negative times a negative is a positive 12m.